All right, so here we've got lesson 5.1b. This is the second lesson in our chapter on trigonometry. This is our first trig lesson. The last lesson was on Pythagorean theorem, which is great. That's a good, useful tool for any right triangle, but we're really going to focus on trig mostly in this chapter. I want to start by looking at this diagram right here. I'm going to go ahead and zoom in on it, so maybe if I is blurry. That's much better. So this diagram is great because it helps us identify the sides of the triangle. When we are doing trig, your top priority should be being able to label the opposite, adjacent, and hypotenuse sides of your triangle correctly every single time. If you sometimes get it right and sometimes get it wrong, you should really kind of slow down and make sure you master that skill because it's going to make a huge difference when you're doing your work. So you might notice that there's an angle marked on your triangle, this symbol right here. It's a little hard to see. I'm going to go ahead and write it at the top of it, make it a little bit bolder. It's a circle with a line through it, and that symbol is called theta. And it's a symbol we use when there's an unknown angle. So I don't know how many degrees this angle is, and that's why they mark it theta. If we actually know the degrees of the angle, then we would put the degrees there. So it's like they just don't want to use an X for an unknown angle. We use X for our unknown sides, but we use theta for unknown angles. Now, directly across from your angle, if you imagine you're standing here, the side you would be looking at is your opposite side. So across from theta is your opposite side. Now, you're also going to have a right angle on every triangle. So if you can identify your right angle, then you can find your hypotenuse. So the hypotenuse is always directly across from the right angle. All right. And then the side we haven't labeled yet, that's going to be your adjacent side. If you look at your focus angle where your theta is, one leg of your angle is going to be your adjacent side. The other leg will always be the hypotenuse. The opposite side doesn't touch your angle. It's across from it, doesn't touch it. So using those three sides, we have three trigonometric ratios: sine, cosine, and tangent. So the sine ratio, we abbreviate SIN, and it's the ratio of the opposite side divided by the hypotenuse. The cosine ratio is abbreviated COS. That's the adjacent side divided by the hypotenuse. And our tangent ratio, TAN, is our opposite side divided by our adjacent side. We use this to help us remember all the ratios. So sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent is opposite over adjacent. So this is SOHCAHTOA. That's how we read it, SOHCAHTOA. It's a good idea to write this at the top of your assignments, or if you're taking a test or a quiz, write it at the top of your paper. So you just have it as a quick reference, so you don't have to try to remember all these. So we're going to go ahead and start with trying to list all the trigonometric ratios for this triangle. So they want us here to find the cosine of x. So x is this angle right here. So I'm just going to mark it. This is my focus angle. Now remember, if you're standing at your focus angle, the side you're looking at straight across is your opposite side. If you're standing at your right angle, the side across from that is your hypotenuse. And the side you haven't labeled yet is your adjacent side. So this problem is asking us to find the cosine of x. So the cosine of angle x. So cosine, if I look here, is adjacent divided by hypotenuse. So this adjacent side is 30. And the hypotenuse is 50. That's all you have to write, 30 over 50. All right, let's try number 2. So this time they want us to find the tangent of angle C. So angle C is here. That makes the side across from that the opposite side. Across from my right angle is my hypotenuse. And the third side is the adjacent side. So we are using tangent this time. Tangent is the opposite divided by the adjacent. So we are going to do 15 divided by 20. So tangent of angle C is 15 over 20. One thing I want to point out is the letter or number that goes next to the trig ratio is always going to represent an angle. And the two numbers that go in your ratio here are always going to be sides. Okay, so our input is an angle, our output is sides. If I were to do tangent of angle A, that would change the input and it would actually give me a different output. All right, so it's kind of important to think about that. All right, sine of angle Z. So this time my input is angle Z. That's my focus angle. So straight across from that is my opposite side. Across from my right angle is my hypotenuse. And the third side is the adjacent side. So we're finding sine this time, and sine is the opposite divided by the hypotenuse. So sine of Z is opposite 15 divided by hypotenuse 25. Okay. All right. Now, we can use this to help us find missing sides of triangles. So let's take a look at number 4. Number 4 gives us an actual angle of 18 degrees. We know one side is 13. There's nothing marked on this side, but this side is marked with an X. So I'm going to go ahead and start by labeling opposite, adjacent, and hypotenuse on my 3 sides. So this is my focus angle right here, which makes this my opposite side. Here's my right angle, so that makes this the hypotenuse. And this is the third side is the adjacent side. You want to focus in on the 2 sides that have a label on them. Our hypotenuse doesn't have any label marked on it, so we don't need that for that side for this problem, but we do need this side and this side. Now, those 2 sides are the adjacent and the opposite. That means we're going to use tangent for this problem. Tangent is the ratio that uses the opposite and the adjacent sides. So I'm going to say tangent of, and I'm going to input the angle here, 18 degrees, equals opposite over adjacent. Now it's really important you remember to put the opposite side over the adjacent side. Don't do it the other way around, you'll get the wrong answer. So to solve these, what we're going to do is we are going to cross multiply. So I'm going to put this tangent of 18 over 1, and that way I have a fraction equal a fraction. That allows us to cross multiply. So I'm going to have 13 times the tangent of 18 equals x times 1, which is just x. And I can just type this in my calculator. So 13 tangent 18. Notice I didn't even have to put a multiplication here. It automatically multiplies it. And I get 4.22395,605, you know, a big old mess. We're going to go ahead and just round it to the second decimal. So we're just going to say 4.22. Oh, no, my mistake. It says round to the nearest tenth. Should have checked that. So 4.2. There we go. All right, let's go ahead and try 5. So on number 5, here's my focus angle. So we're going to start by labeling OAH. So across from the focus angle is the opposite side. Across from the right angle is the hypotenuse. The third side is the adjacent side. So for this problem, it looks like we need to use the opposite side and the hypotenuse. So opposite and hypotenuse is sine. So I'm going to make my problem with sine of 46 equals opposite over hypotenuse. So 11 over x. I'm going to solve this the same way we solved the first one, put it over 1 and cross multiply. So this time I have x times the sine of 46 equals 1 times 11. So that's just 11. So we are going to divide both sides by the sine of 46 so that we can get that x by itself. So 11 divided by the sine of 46 looks just like that. And we get 15.29. So they want us to round to the 10th place. This 9 bumps this 2 up to a 3. So I'm going to write 15.3. And there we go. So one little check you can do on these is just check if your answer makes sense. So we just found the hypotenuse. The hypotenuse should be the longest side. Well, the only other side I know is 11, so I should get a number bigger than 11, but it should be close-ish to 11. It shouldn't be like 300, right? So 11 and a 15, those seem like they could belong to the same triangle, so I'm happy with that. Same thing we could have done with number 4. We didn't find the hypotenuse, so I don't know if it's the longest. It's not the longest side, but I got an answer of 4.2. Well, that is less than 13, and this side definitely looks a lot smaller than this side, so I'm happy with that answer of 4.2. All right, so let's go ahead and work on number 6. So once again, we start every problem by labeling the sides with O, A, and H. So this is my opposite, this is my hypotenuse, this is the adjacent. Then I zero in on the two sides that have labels. That side has a label and that side has a label. Those are the adjacent side and the opposite side. So of my 3 trig ratios, the one that uses opposite and adjacent is tangent. So I'm going to set up my equation using tangent. Tangent of 24 equals opposite over adjacent. So x over 14. Now, this starts off like number 4 did. Number 4 started off with the x on top, the 13 on the bottom. Number 5 started off with the x on the bottom and the number on the top. So as long as you end up with a number on the bottom, you can actually do this little shortcut where you just multiply both sides by that denominator, and it will just cancel it off like that. A little bit less work that way. So now x is by itself on the right, and I just have to type in 14 times the tangent of 24 to get my answer, 6.2. All right, there we go. So that is trig day 1, kind of the basic skill of being able to find missing sides using trigonometry. We're going to be expanding on this, so this is just kind of the entry-level lesson. Please let me know if you have any issues with this, if you have trouble with your homework, and I'd be happy to help you out.